Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on Laplace transformation, lecture number 9, in which we will discuss some examples of change of scale property in inverse Laplace transformation, inverse Laplace transformation of derivatives, inverse Laplace transformation of integrals, inverse Laplace transformation division by multiplication by p and division by p. Now we shall give an example of change of scale property in inverse Laplace transformation. Here example is find L inverse 2p by 2p square plus 16. Let fp equal to p by p square plus 16 equal to p by p square plus 4 square, implies that L inverse fp equal to L inverse p by p square plus 4 square equal to cos 4t, let this is ft, let. Since according to the change of scale property in inverse Laplace transformation, we have L inverse FAP equal to 1 by A ft by A, implies that L inverse f 2p equal to 1 by 2 f t by 2, implies that L inverse, here fp equal to p by p square plus 16, therefore f2p equal to 2p by 2p का और 2p whole square plus 16, 2p by 2p whole square plus 16 equal to 1 by 2 ft equal to cos 40, so ft by 2 equal to cos 4 into t by 2 equal to half cos 2t. This is the required region. Now we shall discuss inverse Laplace transformation of derivatives. Statement: if L inverse fp equal to capital FT, then L inverse f dash b means derivative of small fp equal to minus 1 to the power 1 t ft, and L inverse nth order derivative of fp equal to minus 1 to the power n t to the power n ft. Since given that L inverse fp equal to ft, implies that L ft equal to small fp multiplication by t L t ft equal to minus 1 to the power 1 f dash p implies that L inverse minus 1 f dash p equal to t ft. Since inverse Laplace transformation is linear transformation, so minus 1 will come out, minus 1 L inverse f dash p equal to TFT implies that L inverse f dash p equal to minus 1 to the power 1 t ft. So this is proved. L inverse f dash p equal to minus 1 to the power 1 t ft. Now we shall prove the theorem for nth order derivative. We shall prove this by method of induction. Since for one order derivative we have got this region, so this is fit in this general formula. If possible, let L inverse f(m)p equal to minus 1 to the power m t to the power m ft. Let f to the power mp equal to gp and minus 1 to the power m t to the power m ft equal to gt. Therefore, L inverse gp equal to gt. So we get L inverse g dash p equal to minus 1 to the power 1 t gt implies that L inverse d by dp gp equal to minus 1 to the power 1 t. gt is minus 1 to the power m t to the power m ft implies that L inverse d by dp gp is mth order derivative of fp. This equal to minus 1 to the power m t to the power m plus 1 ft implies that L inverse f m plus 1 p equal to minus 1 to the power 1 and m, minus 1 to the power m plus 1, minus 1 to the power m plus 1, t to the power m plus 1 ft. So it is true for m plus 1. Hence the formula is true for all values of n belongs to n natural number. This is the natural set of natural numbers. So we may write L inverse fnp, nth order derivative of fp, equal to minus 1 to the power n t to the power n ft. This is the required result. Now we shall give an example of inverse Laplace transformation of derivatives. Here, to find L inverse P by P square plus 1 whole square, let Fp equal to 1 by P square plus 1. Implies that f dash p equal to minus 2p by p square plus 1 whole square. Here L inverse fp equal to L inverse 1 by p square plus 1 equal to sin t equal to ft. Let since according to the formula of derivative of inverse Laplace transformation, we have L inverse f dash p equal to minus 1 to the power 1 t ft, implies that L inverse minus 2p by p square plus 1 whole square equal to minus 1 t ft is sin t. Since inverse Laplace transformation is a linear transformation, so we may take minus 2 outside. L inverse p by p square plus 1 whole square equal to minus 1 t sin t, implies that L inverse p by p square plus 1 whole square equal to 1 by 2 t sin t. Now we shall describe the inverse Laplace transformation of integral statement. If L inverse Fp equal to capital Ft, then L inverse integration limit p to infinity small fx dx equal to capital Ft by t. Since given that L inverse Fp equal to Ft, implies that L Ft equal to small fp. We know division by t, Laplace transformation of division by t, ft by t equal to integration p to infinity limit fx dx, implies that L inverse p to infinity fx dx equal to ft by t. This is the required result. Now we shall give an example of inverse Laplace transformation of integrals. find L inverse integration p to infinity 1 by u minus 1 by u plus 1 du. Let fp equal to 1 by p minus 1 by p plus 1 implies that L inverse fp equal to L inverse 1 by p minus 1 by p plus 1 equal to L inverse 1 by p minus L inverse 1 by p plus 1. L inverse 1 by p is 1 minus L inverse 1 by p plus 1 is e to the power minus t. Let this is ft. Since L inverse integration p to infinity fu du is ft by t implies that L inverse integration p to infinity fp is 1 by p minus 1 by p plus 1, fu is 1 by u minus 1 by u plus 1, 1 by u minus 1 by u plus 1 du equal to 1 by t, ft is 1 minus e to the power minus t. This is the required result. Now we shall discuss the inverse Laplace transformation, multiplication by p. The function p, fp is multiplied by p. Statement: if L inverse fp equal to capital FT and f0 equal to 0, then L inverse p into fp equal to f dash t. Since given that L inverse fp equal to ft implies that LFT equal to small fp. We know that L f dash t equal to p L ft minus f0 implies that L f dash t equal to p, this is small fp, Laplace transformation of capital FT is small fp, and f0 equal to 0 given implies that L f dash t equal to p fp implies that L inverse p fp equal to f dash t. This is the required result. Now we shall give an example for inverse Laplace transformation, multiplication by p. Let here fp equal to 1 by p square plus 1 implies that L inverse Fp equal to L inverse 1 by p square plus 1. This is sin t equal to Ft. Let implies that L inverse PFP multiplication by P is F dash T implies that L inverse P Fp is 1 by P square plus 1 equal to d by dt Ft implies that L inverse P by P square plus 1 equal to d by dt sin t equal to cos t. This is the required result. Now we shall discuss the inverse Laplace transformation division by P, that is P is divided by small fp. Statement: if capital Ft is sectionally continuous and of exponential order such that limit t tends to 0, capital Ft by t exists for p greater than a, then L inverse small fp by p equal to integration limit 0 to t capital Fx dx. Since L inverse fp equal to ft implies that Lft equal to small fp. This is number 1. Let gt equal to integration 0 to t fx dx implies that g dash t equal to ft. Also g0 equal to, here if put t equal to 0, then 0 to 0 integration. This is 0 implies that L g dash t equal P L gt minus g0 implies that L g dash t is ft. Ft equal to P L gt means integration limit 0 to t fx dx minus 0 implies that L ft equal to P L 0 to t fx dx implies that this is small fp and p comes left side equal to L integration 0 to t fx dx implies that L inverse fp by p equal to integration limit 0 to t fx dx. This is the required result. Now we shall give an example for division by p. Find L inverse 1 by p into p square plus 4. Let fp equal to 1 by p square plus 4 equal to 1 by p square plus 2 square. Here we give 2, here 1 by 2. So L inverse fp equal to 1 by 2 L inverse 2 by p square plus 2 square equal to 1 by 2, this is sine 2t. Let this is equal to ft. Now we apply the formula for division by p. So L inverse fp by p equal to integration 0 to t fx dx. Here 1 by p, fp is 1 by p square plus 4 equal to integration 0 to t fx is half sine 2x. So here half sine 2x dx, half outside. Integration of sine 2x is minus cos 2x by 2, limit 0 to t, minus outside half and 2, 1 by 4, putting limit cos 2t minus cos 0 equal to minus 1 by 4 cos 2t minus 1 equal to 1 by 4, 1 minus cos 2t. Thank you for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my channel. Thank you.